Hi dear students, here Prof.Anil Darekar. Today we are going to study second part of spectroscopic techniques, that is infrared spectroscopy. In last 3 lectures we studied UV visible spectroscopy. So here UV visible spectroscopy giving us information about the structure of compounds that contain conjugated bonds, double bonds, triple bonds or aromatic compounds. Means simply UV visible spectroscopy help us to identify structure of compounds that contains multiple bonds like a double, triple, conjugated or presence of aromatic compounds. This information we can get by using a UV visible spectroscopy. Now what is the main use of IR, that is the infrared spectroscopy? Infrared spectroscopy provide information about functional groups present in the molecule. Means IR spectroscopy for getting idea about presence of functional groups or which kind of functional groups present in the molecules, while UV visible spectroscopy giving us idea about presence of double bond or triple bond or conjugated bonds. Now here, how to find which type of functionality present in compound? For that purpose we required IR spectrophotometer. IR spectrophotometer. So IR spectrophotometer will give IR spectrum, that is the spectra, and by studying this spectrum or spectra we able to get information about functional groups present in the molecule. Now how it work? Here IR radiations produced by source. Now that radiation absorbed by sample. Now here IR radiation range from 0.8 to 200 micron, or this 200 micron is in wavelength and this 2500 to 50 centimeter inverse. This is wave number and this one is wavelength. So here absorption of selective IR radiation. Selective IR radiation, that is from the range of 0.8 to 200 micron wavelength. Right. So here selective IR radiations getting absorbed by the sample. In sample molecules are there. In molecules atoms are there. So here atoms get energy. Who provide energy? IR radiation provide energy after absorption. So here range 0.8 to 200 micron. So here out of this range some specific radiation, specific wavelength radiation get absorbed by sample. So here atoms getting energy. Right. So after absorption of energy, atoms or whole molecule start vibrating. So here vibration take place after absorption of energy. So here atoms or molecules start vibrating in different ways. Means in different ways vibration taking place. Who getting vibrated? Atoms getting vibrated or molecules getting vibrated. Now here produce after vibration of atoms or molecule, it produces absorption bands. What it produces? It produces absorption bands in the spectra, that is in the spectrum. Right? Each band gives specific information about functional group present in the molecule. Each band, or you can say each peak, give information about functional group present in the compound. Okay, so in this way we able to find which type of functionality present in the compound. I will repeat again. Here absorption of IR radiation by sample. So selective radiation getting absorbed. So after absorption atoms getting energy. So after getting energy they start vibrating. Now because of that vibration it produces bands, that is the peaks in the spectra. That peaks or bands giving a specific information about the functional group. Now here, as I said, range of IR region, that is in wavelength or in wave number. Now wavelength lambda, here range 0.8 to 200 micron, right? And here if we find wave number, then wave number nu bar, that is 12,500 to 50 centimeter inverse. Now what is mean by wave number? Wave number means number of waves. Wave number means number of waves per unit length. Number of waves per unit length. So here wave number nu bar, which is equal to 1 upon lambda, and here this value of lambda is in a centimeter. Now here first we have to convert this wavelength micron into centimeter. So here lambda 0.8 to 200 micron, which is equal to 0.8 into 10 raised to minus 4 centimeter. Means what? Here 1 micron, which is equal to 1 into 10 raised to minus 4 centimeter. Right? Here I am talking about wavelength. Okay, so wave number, that is micron convert into centimeter, and this centimeter value we are going to put here for finding a wave number. For example, lambda value, that is a wavelength value 0.8, right? So 0.8 micron, so we have to multiply by 10 raised to minus 4. So here this is a wave number which is equal to 1 upon lambda, value of lambda in centimeter. So here 0.8 into 10 raised to minus 4 centimeter. As I said, 1 micron, which is equal to 1 into 10 raised to minus 4 centimeter. So here 0.8 into 10 raised to minus 4 centimeter. So here we are getting wave number 12,500 centimeter inverse. Okay, so in this way we able to find wave number if we know wavelength. Now here we will see principle of IR spectroscopy. Atoms in any molecule, as you know, molecule is made by combination of atoms bonded with one another, and we get a molecule. So atoms in any molecule, right, and molecule as a whole, means complete molecule, is never stationary. Means atoms in molecule are not stationary, or whole molecule is not stationary. They always rotate, vibrate and move from one point to another point. Means rotation is there, vibration is there, movement is there from one point to another point. So here atoms in molecule can vibrate in number of ways. Atoms in molecule can vibrate in number of ways, means in different ways vibration can be possible, and here each vibration required a definite amount of energy, or you can say each vibration required specific amount of energy. If molecule absorb IR radiation, then it get excited to higher vibrational energy level. As you know, if atoms absorb energy, right, then it start exciting to higher energy level. Now here after absorption of energy, vibration take place. So here after absorption, excitation take place to higher vibrational energy level. Now here the sample or the molecules absorbing IR radiation, specific wavelength IR radiation. Now which one wavelength to absorb, that depends upon the types of atoms and chemical bonds present in the molecule. Try to understand. Here I am telling IR radiation range from 0.8 to 200 micron. So out of, or you can say from the range of 0.8 to 200 micron, specific wavelength range is absorbed by the sample, by the molecule. That type of IR wavelength absorbed by molecule depends upon types of atoms and chemical bonds. Means here atoms and chemical bond will decide which one type of wavelength, right, to absorb. So this is about the principle of IR spectroscopy. Now here we are going to see types of vibrations that taking place in the molecule. As I said, the time when molecule absorb radiation, vibration take place too. That is a vibration take place. Now here we will see types of vibration. Atoms in molecule are covalently bonded to one another. Here atoms in molecule are covalently bonded. Here bonds are elastic, not rigid. Means all covalent bonds are elastic, like a spring, and they constantly vibrating with certain frequency. Try to understand. Here atoms in molecule are covalently bonded. Here bonds are elastic, not rigid. So here bonds are elastic, means bonds behave like a spring and they constantly vibrating with certain frequency. vibrating because they are elastic with certain frequency. Now here we will see types of molecular vibrations. So two types of molecular vibrations are there: stretching vibrations and second one bending vibrations. Stretching and second one bending. One by one we are going to see. So first one, stretching vibrations. Now here, how to characterize that stretching vibrations taking place? Here, stretching vibrations are characterized by change of internuclear distance. Stretching vibrations characterized by change of internuclear distance means distance between two atoms changes. Right? So here you can see this diagram, A atom and B atom. Right? This is the bond length between A and B atom. Now this is the normal. When we stretch, here bond length increases. When we stretch, bond length increases, right? And when we compress or when we contract, bond length decreases. So this is the stretching vibration. So in case of a stretching vibration, bond length either increases or decreases. Bond length between two atoms either increases or decreases, right? So this is characterized by change of internuclear distance. Now here, stretching vibrations classified into two types. In that first one, symmetrical stretching, and second one, asymmetrical stretching. Symmetrical stretching and second one, asymmetrical stretching. In both stretchings, atoms remains on same bond axis. Try to understand, there is a bond axis. During stretching, atoms remains along the same bond axis. Now here, one by one we are going to see. First one, symmetrical stretching. Now here, symmetrical stretching, word itself telling us stretching take place symmetrically. Right? Stretching take place symmetrically. Right? Means in stretching vibration, here both bond length increases or decreases. In case of symmetrical stretching, here bond length either increases or decreases, and this one take place symmetrically. So bond length means which one? For example, this is a central atom and this central atom bonded to these two atoms. Now here I am telling, in symmetrical stretching, bond length either increases or bond length either decreases. Now this increase or decrease take place symmetrically. Increase or this decrease take place symmetrically. Okay, so in first diagram you can see here stretching take place, right? Here bond length increases, and in second presentation bond length decreases, right? So this one take place symmetrically. So here you can say vibration take place in and out together. Vibration take place in and out together. Vibration take place in and out together in same direction. In same direction along the bond axis. Okay. So this is a symmetrical stretching. Simply bond length either increases or bond length either decreases. Now this increase or this decrease take place symmetrically at the same time. Okay. So these are symmetrical stretching. Now second one, asymmetrical stretching. In case of asymmetrical stretching, one bond length increases, means you can say length of one bond increases while length of other bond decreases. See, these are the original position of atoms. Here I said length of one bond increases and length of second bond decreases. Means one, right, here stretch and second one contract. Okay, so length of one bond increases, length of second bond decreases. This is called as a asymmetrical stretching. Now second type of vibration we are going to see here, that is a bending vibrations. Now bending word itself telling there is a change in bond angle. So how to characterize? It is characterized by change of bond angle. Now here bond angle between two covalent bond. Bond angle between two covalent bonds, that bond angle changes. In symmetrical stretching, asymmetrical stretching, that is a stretching type of vibration, we studied that bond length changes. In case of bending vibration, what changes? Bond angle changes. Now here, in case of stretching vibration, I said here atoms remains along the same bond axis. In case of bending vibration, position of atoms relative to original axis changes. Means original axis of atoms changes. Why? Because bond angle changes. Because bond angle changes. So here we will see types of bending vibrations. So types of bending vibration, 4 types of bending vibrations are there. In that first one, scissoring, rocking, wagging, and last one, twisting. Scissoring and rocking take place in the plane, means in the axis, or you can say in the plane. This scissoring and rocking take place. Here wagging and twisting take place out of the plane. Now one by one we will see. First one in the plane, that is the scissoring. Scissoring like a scissor. Here in case of a scissoring, bond angle decreases. In case of a scissoring, bond angle decreases. And here atoms move towards each other. Atoms move towards each other or away from each other. Now you can see these are the atoms and their original position. Now here atoms move towards each other. Atoms move towards each other. So this is what? This is a scissoring, right? So here atoms move in opposite direction. Now this atom move in clockwise and this atom move in anti-clockwise. Try to understand. First one atom move in clockwise and second atom move in anti-clockwise. Okay, so in scissoring, bond angle decreases. You can see this is the original bond angle and this is a new bond angle after movement. Okay, so in scissoring, bond angle decreases as atoms move towards each other or away from each other. So here atoms move in opposite direction. One in clockwise, second one in anti-clockwise. Then next one, rocking. Rocking like a rocking chair. Forward, backward. Forward, backward. Here bond angle remains same. Bond angle remains same. See, example like a rocking chair. Rocking chair structure remain constant, right? Folding of chair will not take place. Simply chair move forward and chair go backward. So here in rocking, bond angle remains same, while in scissoring, bond angle decreases. Rocking, bond angle remains same. Simply atoms move forward, backward. Forward, backward. So here movement of atoms take place in same direction. You can see this atom move in clockwise, same way this one atom move in clockwise direction. So atoms move in same direction, bond angle remain constant. So this is a rocking. Now third one, wagging. So here we will see how wagging take place. In case of a wagging, both atoms move to one side of the plane with respect to central atom. Try to understand, in case of wagging, both atoms move to one side of the plane. Means either up or below the plane. Either up or below the plane. Both atoms move either up the plane or below the plane. So if both atoms move up the plane, then here positive sign. If both atoms move right below the plane, then negative sign. Below the plane, negative. Both atoms above the plane, positive. Twisting. In case of twisting, one atom move up the plane and other atom move down the plane. One up, second down, or second up, first down. Try to understand. So here one atom above the plane and other atom below the plane. So one atom above, positive sign. Second atom below, negative sign. So these two, wagging and twisting, these two take place out of the plane. Out of the plane, because here in wagging either both atoms move above the plane or below the plane. And in twisting, one above the plane and second below the plane. Right? Means here movement take place out of the plane. So wagging and twisting, these two movement or these two vibration taking place out of the plane, while scissoring and rocking, just now I said scissoring and rocking, these two taking place in the plane. In the plane. Right? Because simply here bond angle in case of scissoring decreases and in rocking remain constant. Rocking atoms move forward or backward. Forward or backward. And in scissoring simply atoms move towards each other or away from each other. Towards each other or away from each other. Right? Here scissoring I said atoms move in opposite direction and in rocking atoms move in same direction. So here dear students, in today's session we studied principle of IR radiation and then we studied important types of vibration, that is the stretching vibration and bending vibration. In stretching we studied symmetrical and second one asymmetrical, right? And in bending we studied scissoring, rocking, wagging and twisting. Main difference between stretching and bending vibration. Stretching vibration bond length changes and bending vibration bond angle changes. Try to understand. Stretching bond length changes and bending bond angle changes. Thank you. Thank you for watching.